Hello everyone, welcome back to my channel. My name is Atharva. Today we are going to dive into an exciting topic in artificial intelligence and natural language processing, cross-lingual language model. This is also known as XLM. This presentation will explore what these models are, how they work, and why they are so important in breaking down language barriers in our increasing connected world. By the end of this video, you will have a clear understanding of the application, limitations, and the future of cross-lingual AI. Understand what is cross-lingual model? A cross-lingual language model is an advanced AI system trained on data from many different languages. Unlike simple translator such as Google Translate, we just map words from one language to another. Cross-language models actually learn the deeper structure and relationship between languages. This allows them to perform not only translation but also tasks like question, answering, summarization and text generation in multiple language. याचं उदाहरण असं की आपण कुत्राला इंग्लिशमध्ये डॉग म्हणतो, स्पॅनिशमध्ये पेरो म्हणतो आणि मराठीमध्ये कुत्रा म्हणतो. This shared representation makes the powerful multi-language tools. Now we will see a simple example. Here input is given as Je suis étudiant. This is in French. We don't know French. So our machine will decode it in English and the output will come as I am student. Now we will learn the how they are differ from other models. First model is monolingual models, such as original bird and trained in just one language. They perform well but cannot transfer to other languages. The second model is multilingual models. That models are trained on multiple languages but they don't explicitly align or connect to those languages. So while they can handle several languages, they often struggle with transfer learning. And now we will learn cross-lingual models. Cross-lingual models go step further. They are explicitly designed to connect languages through shared representation. That's why if you train them on English, they can often perform surprisingly well on French, Hindi, or even Swahili without retraining. Now we will learn cross-lingual language model working process. The working process divided in three stages: pre-training, fine-training, and deployment. In pre-training, this is optional but very common. This model is trained on massive multilanguage datasets. During this stage, we use techniques like masked language modeling (MLM), where the model predicts missing words, and translation language modeling, where it predicts missing words across pair of translated sentences. Let us understand cross-lingual language model working process. We can think a cross-lingual language model as a working in two main steps, with an operational extra step at the beginning if the model is being built from scratch. First one is pre-training, second one is fine-tuning, and third one is deployment. Now we will see the pre-training. One is pre-training. This step gives the model general multi-languages knowledge before specific tasks. First one is data collection. The first step is to gather large and diverse text from multiple languages. This data typically comes from various sources including books, news articles, websites, social media content, Wikipedia. Second is data cleaning. Once the data is collected, it often contains unwanted element or noise, which can hinder the model's learning process. Data cleaning is the process of removing or correcting these issues. Some common tasks in data cleaning include removing irrelevant or low quality text, fixing formatting errors, handling special characters or symbols. Third one is tokenization. Tokenization is the process of converting text into smaller units, such as words or subwords. That's the model can understand. Since a language model cannot directly work with raw text, it breaks the input into pieces that are represented as numerical value. For example, I love programming. That is divided in I, love, and programming. Fourth one is model architecture. The model architecture used in pre-training is typically transformer-based. Transformers are highly effective for processing sequences of text and have become the standard architecture for large-scale language models. The transformer has two main components: encoder and decoder. Encoder capture the input sequence and decoder generates the output sequence. And the last one is pre-training techniques. There are multiple pre-training techniques including MLM and TLM. MLM means masked language modeling. In MLM, some words in a sentences are randomly masked and the model's task is to predict these masked words based on the surrounding context. For example, original. The cat sat on the mask. Model's job predict that the masked word is mat. And second one is translation language modeling, TLM. TLM is the extension of MLM, but instead of just missing words in one language, the model is trained with pair of sentences. Example, English sentence, I like apple. French translation, Jamie likes poems. And the last one is training. Training a language model requires significant computational power and involve fine-tuning the model using a large data set. Key metrics during training include perplexity and masked word accuracy. Training typically takes place on a powerful hardware, example GPU, TPU, to handle the massive amount of data and calculation required. Whoa! These images show a difference between MLM and TLM. The sentences is take a seat and have a drink now. The missing word is a take a mask, seat and mask a drink now. The MLM will only suggest the English words, but TLM also can predict the French words missing in that sentences. Now we'll understand the stage 2. Stage 2 is fine tuning. After the model has been pre-trained, fine tuning is the next step where the pre-trained model is adapted to perform a specific task. This step is essential to ensure the model's general knowledge is specialized for practical application. It have divided in multiple steps. First one is the choose the task. The first step is fine tuning is the selecting the specific task the model will be used for. Some common tasks include machine translation, question answering, summarization. Second one is prepare task specific data. The model is then trained on smaller task specific data that is cleaned and tokenized. The dataset directly relates to the task at hand and is much more focused than the pre-training data. For instance, if the task is machine translation, you would use a parallel corpus of sentences in two languages. For question answering, you need a dataset of questions paired with the appropriate answers. For summarization, you would use dataset containing long document paired with their concise summarization. Third one is fine tune the model. Fine tuning involves training the model on task specific data. This step typically involves adjusting hyperparameters to improve the model's performance for the particular task. Stage 3 is deployment and use. Once fine tuned, the model can be deployed and used for real world tasks. This is where the model's capabilities come into practical use and it can provide valuable services. Here are some examples of deployment: machine translation, multilingual content creation, customer services. The next one is what is NLI? Natural language inference. The natural language inference is a fundamental task in natural language processing (NLP), where system is given two sentences and must determine the logical relation between them. The key components are premise and hypothesis. Premise is this is the original or given sentences. Example: it is raining outside. And hypothesis is this is second sentences that might logically follow, contradict, or be unrelated to that premise. Means if it's raining outside, then the ground is wet. The system jobs is to determine how the hypothesis relate to the premises. These have three possibilities. First one is entailment, contradiction, and neutral. In entailment, the hypothesis must be true if the premise is true. Means it is raining outside, so the ground is wet. Logically, it is true. Next one is contradiction. The hypothesis is clearly false if the premise is true. Premise is it is raining outside, so hypothesis should be it is sunny outside. It is contradiction. And third one is neutral. The hypothesis might be true or false, but we can't tell based on the premises alone. Premise is it is raining outside. Hypothesis people are inside their homes. Neutral. People might be inside, but the premise doesn't confirm it. Why NLI matters? It helps machine understand meaning and logic in sentences. Used in tasks like question answering, summarization, dialogue system, information retrievals. Now we will see the what is XNLI. XNLI. XNLI stands for Cross-Lingual Natural Language Inference. It is both a dataset and a benchmark, designed to test how well natural language inference models perform across multiple languages. Goal of XNLI. The primary goal of XNLI is to assess whether a model trained on one language can be applied to other languages without needing additional training or adaptation for each language. In other words, it tests the cross-lingual transfer capability of NLI models. How XNLI was created? Started with MNLI dataset. Multi-general natural language inference dataset was used as the starting point. This dataset contains NLI example with English across 10 different genres. Example: news, conversation, fictions, etc. Second is translation to other languages. 7500 English examples from MNLI were selected and transferred into 14 other languages. The translation process was done by professional human translator to ensure accuracy. The final dataset become total size equal to 7500 examples into 15 languages is equal to 1,12,500 examples. This includes 15 languages like English plus 14 other translated languages like French, German, Japanese, Arabic. The data is split into development set and test set. Development set include 2490 examples per language used for model tuning and 5010 examples per languages used for final evaluation. Next one is training process. No separate training needed for XNLI. Models are trained only on English MNLI data and then evaluated on other languages from the XNLI dataset to test how well they generalize to new languages. In short, XNLI is a multilingual extension of the MNLI dataset aiming to evaluate cross-lingual NLI models. It was created by translating English NLI example into 14 other languages and it is used to test whether models trained on English can perform NLI tasks in language without additional language-specific training. Thank you. This image shows the transformation of words. Here, English language is converted into other 14 languages, and each have 249 example per language. An excellent dataset of 5,100 example per language. Now we will understand the how XNLI is used. XNLI can be used in three main ways to evaluate how well models perform NLI across multiple languages. Each approach has its strength depending on how the model is trained and evaluated. Here's an explanation of the three methods. First one is standard cross-lingual transfer. Train a model on English MLI only. Test it directly on other languages in XNLI. This is the main purpose of XNLI. Example, train on English. Test on Hindi without extra training. Second one is translate test. Translate the test from other languages to English. Use an English model for evaluation. Work well if machine translate empty is good. And third one is a translate train. Translate the English training data MNLI into many languages. Train a multi-language models on all languages. Example are models like XLM, XLMR, MT5. Needs a lot of computation but gives best performance. Now we will see the example of cross-lingual language models. First is MBERT, multilingual BERT. What is it? A multilingual version of BERT trained on 104 language using Wikipedia data. How it works? Encodes multiple language into a shared representation space, allowing it to handle multiple languages at once using masked language modeling to predict missing words. Use case: allow performing various NLP tasks like classification, question answering across multiple languages without needing separate models for each language. The second one is XLM, cross-lingual language models. Purpose: to extend BERT for better cross-lingual understanding. Key features are introduce translation language modeling, which combines masked language modeling with parallel sentences in different languages to improve multi-language tasks. Benefits of this is learn language agnostic representation, making it more effective for translation and other multi-language tasks. In short, MBERT is a multi-language for handling tasks in multiple languages with single model, and XML builds a BERT to improve cross-language tasks by using both MLM and parallel sentences. The third example is XLMR, XLM Roberta. What is it? An improved version of XLM based on the Roberta architecture. Improvements is trained on 2.5 TB of common crawl data in 100 languages, leading to better performance on multilingual tasks. The key features of this is better performance on tasks like XNLI, cross-lingual question answering, and named entity recognition. Provides state-of-the-art result for multilingual understanding. The fourth one is Laser, language agnostic sentences representation. Developed by Facebook AI. How it works? Uses an encoder-decoder architecture and is trained on parallel text from 93 languages to generate language-independent sentences embedding. Applications are cross-lingual document classification. Classifying documents in different languages with a single model. And second one is sentences similarity across languages. Comparing sentences meaning in different languages by leveraging a common embedding space. In short, XLMR is a robot version of XLM, offering better performance on multitasking tasks like cross-lingual QA and NER, training on large multiple corpus. And Laser is a language-agnostic model for generating sentences embedding useful cross-lingual documents classification and sentence similarity across languages. Cross-lingual language models. First one is biased data. XML can reflect biased in their training data, leading to unfair outcomes. Example, if trained on biased data, a model might favor certain genders or ethnicities when making hiring recommendation. Second one is limited reasoning. XML struggle with tasks requiring common sense or world knowledge. Example, XML might fail to understand that if it's raining, people use umbrellas, even though it is a common fact. Third one is high resources needs. XMLs need a lot of computational power, making them expensive to train and use. Example is training a multi-language models like XLMR require powerful GPUs, which can be costly for small business. Third one is lack of transparency. XML often act as a black boxes, making it hard to know why they make specific decisions. Example is if XLM give an incorrect translation, it's hard to understand why it made an error. Fifth one is vocabulary gaps. XLM struggle with rare languages or specified terms. Example, an XLM may mistranslate technical jargon in field like medicines or law as it wasn't trained on enough specialized data. Our video. Cross-lingual language models XLM are transforming how we interact with information across language. By processing vast amount of text from multiple languages, they excel at translation tasks, ensuring smooth communication and knowledge sharing across linguistic boundaries. These models are playing a crucial role in fostering a more connected and inclusive global society, breaking down language barriers and enhancing accessibility to information for people worldwide. Despite challenging like data bias and high communication costs, XLM continue to evolve and improve, paving the way for a future where language no longer limits our ability to connect and collaborate. The potential for these models to bridge gaps, empower diverse communities, and democratize access to knowledge immense. In a sense, XLMs are powerful tools for building a world that are more unified and inclusive. Thank you. Share my channel and like the video.